Okay, I got the students started with a couple of ones we should practice to help them get ready for the final. And they're going to work on these two questions for a minute, and then we'll resume and see how to do them. Okay, so this one is easy if you know how to start. What should you change ln into? Log base e, and that brings in an extra e. And that makes you realize, oh, I've got a base of an e, and I could make this one have an e. So then it's about, can I make it e to a power? Well, what power would it be? This would be e to the power of, it's a fraction. And the power goes on top, that's a normal power. The root power, which isn't shown, is a 2. So that goes on the bottom. How many of you had 3 over 2? Awesome. Now there's a common mistake answer, and it's a kind of a like nasty twist. Let's say this is multiple choice. I'm not saying there's some multiple choice on the test. They put this in as a option for the answer. Do you get that? Is not the right answer. You get the difference? Because the e's are the same, the answer is this part. Get how that's a kind of a nasty twist? Like kids thinking, oh, it's e to the 3 halves. It is, but that's not the answer. All of this simplifies to 3 halves. Okay, this next one. If you have two logs, you should combine them. So it goes together and becomes log base 2 of 4 times x plus 1. No, that is the most common mistake because we did so many of those. What does this minus mean I should have done to them? Divide them. So I'm going to take 4 divided by x plus 1. Oh, no, wait, the other way around. This one's first. So x plus 1 divided by 4. Does it make a difference? Definitely does. So this one's first, so it goes in there first, x plus 1. And you guys know that order matters in math. Going from left to right when you're tied on things is the way to go. So that one's first, and then the 4 is next, and then it equals 3. Then from there, you would probably get stuck, which is why I'm bringing this problem up. It's got two important things. It's got the condensed part, and then it's got the I'm stuck. You should rewrite. And you'll have 2 to the third equals x plus 1 over 4. And 2 to the third is really 8, so keep on making your problems simpler and simpler. X plus 1 divided by 4. And then I'm going to multiply both sides by 4 to clear the fraction. And this was a 1 right there. So this is 8 times 32 equals x plus 1. Subtract 1 from both sides, and I have 31. Did anybody else get 31 before I said it? Awesome. Then you are pretty good at logs. That's awesome. All right, so what else do you have to know? Well, tons of things, and I don't want to just make you do practice problems all hour, but I got a few more that I figured I know that, you'll have to do something in this realm, and I wanted to prep you as good as I could. Secant. I would refuse to do secant. I would do the other one. And I would figure out where 7 pi over 6 is, and then I would draw a triangle. You always drew triangles. You always figured out what the sides were. You were always careful with the negatives. All right, I'm going to pause for a second while you try to figure out secant to 7 pi over 6. Okay, so this is making you review two things. The other 3 trig functions, and where in the heck is 7 pi over 6 radians? Well, here's where 1 pi over 6 is. It's 1/6 of the way to pi. Then if I kept going, that would be 6 pi over 6, and one more would be 7 pi over 6. So now I'm drawing my triangle. Normally I say if I don't know how the triangle looks, I make it short and fat, but I know this one because I know this is a 30-degree angle. So I know it's one of the long, skinny ones because pi over 6 is 30 degrees. So always label all the sides. If this is a 30, this is a 1, this is a 2, and this is a square root of 3, and there's negatives here and here. Now I could do anything. If they ask me tangent, easy. If they ask me sine, easy. But what did they ask me? Secant. So you figure out cosine And do you flip the angle over? No, you never flip angles. It wouldn't make any sense. You flip the sides. So you figure out cosine and you flip the answer. So cosine of 7 pi over 6 flipped. I'm just writing that to, don't forget, at the end you gotta flip it. Cosine of 7 pi over 6 would be adjacent over hypotenuse, negative root 3 over 2, and then you gotta flip it. 2 over negative root 3, and the negative can go wherever, it doesn't really matter. Raise your hand if you had that before I did. Awesome, you remember tons of trig then. But do you remember what to do when you have a weird problem involving trig? Tangent x cosine x plus tangent x equals 0. I'm going to give you the last 3 questions that I have. There's that one. There's this one. Inverse cosine of 1 over root 2 will remind you how those inverse trig things work. And then this one, last, sine of inverse tangent of 1. Always start those on the inside. If you have forgotten these things and they're scary, then that's why we're doing this. I'll remind you in a minute. But confer with the kid next door. If you're like stuck, ask them if they remember. So, for the millionth time, a whole bunch of kids are probably stuck on a problem that gets solved by factoring. You gotta notice there's tangent in both of them. You factor it out, and you have cosine x plus 1 left over. If you're not sure how that just happened, I realized there was a tangent in both of them, so I divided by tangent here and here, and I was able to pull it out to the front, and what's left here is just cosine, and what's left here is just a 1. And there's my answer. No, there's my factoring, which then leads me to tangent must be 0. Ooh, that sounds like a quadrantal. So how do I do tangent is 0? I look for tangent is y over x. Tangent of theta is y over x. So I want y over x to be 0. So the whole thing equals 0. What would make that 0 is if the top was 0 but the bottom was not. How do I find a spot where y is 0? Well, y is 0 here and here. Those are 2 spots where y is 0. I'm going to call this one out. It's 1, 0. And this one's negative 1, 0. And either one of them would work. So there's 2 answers. These 2 spots. What am I looking for? Angles. What are the 2 angles? 0 and pi. Now, cosine has to be cosine plus 1 has to be 0, so cosine has to be negative 1, and I'm starting to get nervous that I might have one of those kind where one of the answers doesn't work. We'll find out. What if it had said cosine equaled like negative 2? That would never be true, because cosine never goes down to as far as negative 2. But cosine being negative 1, that exists. It does. I know there's a spot where x, cosine is the x over r. I know there's a spot where x is negative 1, and that would be there, which would be pi. You get with me that that's pi? Now I have to be sure, did I, in my list of answers, which were 0 and pi and another pi, so it's just 0 and pi, are any of those going to kill cosine? No, you can't kill cosine. Its domain is everything. Cosine can go forever. But tangent, remember the deal with tangent? Tangent has asymptotes. That means it can't be those things. So tangent, you have to watch out for pi over 2 and negative pi over 2, aka 3 pi over 2. And did I say one of those was the answer? No. But I watched out for it because tangent can be killed by putting in the wrong angle, if you put in one of these 2 angles. But I didn't say one of those 2 was the answer. So then my answers are just 0 and pi and another pi, which is just 0 and pi, the end. I just thought I'd double check because I betcha that there's one on the test where you can't, it doesn't work. Like the angle you would put in would make the trig function either 0 on the bottom of an equation, or it would make the tangent not exist. So watch out for those. Okay, and then there was this one, inverse cosine of 1 over 2. And in case you completely forgot how inverse cosine works, it's like, and I actually would write this when we had this unit, it's like cosine of the angle equals 1 over root 2, but there's restrictions. The restrictions are that cosine is only allowed from here to here. If you haven't got that document memorized yet, I did redo it on one of my the second day of review for the final. This is where inverse cosine is allowed. And cosine is positive. See, there's no negative there. So if cosine's positive and it's only allowed in these two spots, it must be here. Because cosine would be negative right there, so that's out. All right, so now cosine is adjacent, hypotenuse. Oh yes, the 1, 1 root 2. If it's a 1, 1 root 2, then it's a 45. If it's a 45, then it's pi over 4. Anybody have that before I did? Sweet. We're doing really well. And then last but not least is this one. Now what's special about this one is that you have an inside and an outside to it. And you got to know both inverse trig and regular trig, because you won't be able to answer it with just inverse trig. At the end, you'll have to do regular trig. So you start with inverse trig, though, and you ask yourself, tangent of some angle is equal to 1, but I always want to have that reminder, this is inverse trig, so where is inverse tangent even allowed? Only here and here. If you hadn't memorized that, memorize it. It's going to come up at least a couple times on the final. Then, where is tangent positive? Up here. So it can't be there. So then tangent is 1 over 1. 1, 1. Tangent is opposite over adjacent, right? This is 1, 1 root 2. That's the 45-degree angle. So the answer is 45 or pi over 4. Now the end of the problem is you just figured this out. And this was pi over 4. So then the final question is, what's sine of pi over 4? Sometimes you can use the same triangle, and I can, because this is where pi over 4 actually lives. Sine of pi over 4, then, is opposite over hypotenuse, which is 1 over root 2. Final answer. Wait, I thought we were supposed to give an angle. Nope. At the end, you were doing sine of an angle we already knew. We were doing sine of the angle. So the sine is an opposite over hypotenuse. It's a ratio of 2 sides. Okay, there's my last tips for today. That should get you a little bit more ready. Tomorrow is our last day of review for the final. I have a few more problems primed up for that. Your only job between now and the end of the day today is, if you have any missing tests, you should be talking to me about taking that tomorrow in class, because I can't just if you have a missing test, I have to put an incomplete in there, and then you'll have to come in the summer to take a test. That would really suck. So, bottom line, strongly recommend if you're missing any tests, you talk to me about that today and take it tomorrow. You could also come up and ask me questions about the packet. The packet is going to be turned in, but not until you actually take the final. So when you come into this room to take the final for you guys, is it Wednesday? Yeah. Okay. On Wednesday, you can get your points for that last piece of homework, the formative points for the packet. So do that, and it's going to help you for the study for the final. Okay, and then the only other thing I want to mention is that on Wednesday morning, there is a morning help time, like before all the finals start. It's like 2 hours long. You can come in and get out in that. That would be perfect. Especially for you guys, it'd be perfect, because you can do some lash brush up right before you take the test later that morning. So I am available Wednesday morning for extra help. That's all I got for you for today.